In the last video, we looked at section 5.2, which described the definite integral, and there we learned that the definite integral gives us the area under the curve or under the function, or area between the x-axis and the function. So in this section, the fundamental theorem of calculus, section 5.3, we are going to look at a special kind of definite integral in which the upper limit is a variable. So if you note here, the upper limit is a variable, and this is a way of defining new functions. So we are defining a function g of x as an integral of the function f, and so using an integral sign. But we say, or we are saying, that what this represents or what this gives us is basically the area function. And idea is that from the integral from a to b, so if we have integral from a to b, that gives us the whole area under the function f in this diagram from a to b. But if there are values, we define a variable x which varies between a and b, then the integral from a to x f of t dt will give us the area under the function f of t from a to x. So we call it the area function. So what it means is that we are always starting with a and going up to whatever the x value is. So example, and this is something that you must have seen in Calc 1 as well. So the graph of a function f is given. So here is the graph, and we are defining a new function which is, remember, the area function. So g of x is defined from 0 to x and y from 0, because we are starting our function at 0. So now we can define it from any place after 0 where the function is defined, but not like before 0, because if we start it before 0, we have to have some function there. So this is our function f, and now we have to find the values of these four quantities. So we start by the first one, which is g of 0, and we will start by writing its definition. So according to the definition, we will replace the x by 0 in our function. So we are going to go from 0 to 0 f of t dt. Okay, so this is supposed to be t. Then, if you recall from before, from last video, this by one of the properties of the definite integral, this is just 0. Now what is g of 1? Well, again, we will start by writing the definition. So it will be from 0 to 1 f of t dt. So which means it is the area between between the point 0 and 1 and under the curve. So which means the area of this small rectangle over here, small triangle here, so which is 1/2 times 1 times 1, so which is 1/2. And then we are going to look at the next value, which is g of 2. So g of 2 is integral from 0 to 2 f of t dt. And so now it will be the area between 0 and 2, and so it's the area between this of the triangle triangle that we already have, plus the area of this square. So that we have 1/2 plus 1 into 1, which is 1, so we have 3 over 2. Okay, so the next one is the value g of 8, so which means integral from 0 to 8 f of t dt, which again means the area, the net signed area. So basically this will be the area of the area above the x-axis minus area below the x-axis. So this will be equal to the area of this trapezoid over here on the top. So this area minus that area and then plus this area. So we already have up to 0 to 2, we already know that is 3 halves, and now we just need to add the area of this little triangle there, which we know is again going to be 1 half. So we have 3 halves plus 1 halves minus the area of the portion below the x-axis. Now you can use the formula for area of a trapezoid, or you can divide it into two triangles and a rectangle. So it will be minus 1 half plus 2 plus 1 half, and then plus 1 half from the top. So add everything up and you will notice that you end up getting, so I have 3 over 2 plus 1 half plus 1 half here, so this makes it 5 over 2, and the minus I have 3, so which gives us negative 1 half. Then now we look at the definition of fundamental theorem of calculus, part 1. So remember, there are 2 parts of fundamental theorem of calculus. The first part says that if we have a function, or in other words the area function, or the function g of x defined by an integral in this form, then the derivative of g is equal to f of x. So note here we have f of t, up here we have x, so we end up getting g prime of x is equal to f of x. And in other words, we can say that the g of x is actually the antiderivative of the function f. So if we are now asked find the antiderivative of the function f of x is equal to e to the minus x square, well, we don't know the antiderivative directly, but we can say the antiderivative, we can define it by using the definition of the integral. So we can say this is equal to from a to x. So we can actually start with anywhere from 1 to x e to the minus x square dx, or you can go from, so this is one of the antiderivatives. So remember, we have many antiderivatives for a function, so it depends on where you start. So 1 to x, 0 to x, 2 to x, negative 1 to x, wherever you start. So it just says find an antiderivative, so we have to give just one antiderivative. The next example asks find g prime of x when g of x is given like that. So note here, the f of t here is arc sine of square root of t square plus 1. And by ftc, g prime of x is equal to f of x. So which means it will be arc sine of square root of x square plus 1. That's it. We are not integrating anything. We are not differentiating anything. Just using the definition of the fundamental theorem of calculus. The second part of the fundamental theorem of calculus actually helps us solve or evaluate the definite integral, and it goes like this. So we can use that property and solve the couple of examples here. So the first one, we have this. Now notice here there are two functions which are being multiplied, and we do not have any rule, any product rule for integration. So our best choice, also notice here that we don't know the antiderivative of tangent yet. So but if we multiply it out or distribute, so we end up getting secant square t plus secant t times tangent t dt. Then the functions that I have now are familiar, so we know the antiderivative of these functions. So what is the antiderivative of secant square? It's tangent. And what is the antiderivative of secant t tangent t? It's secant t. And then I'll put the limits like that on the right hand side, and then we will just now plug in the limits. So plugging in the limits gives me tangent of pi over 4 plus secant of pi over 4 minus tangent of 0 plus secant of 0. Now tangent pi over 4 is 1, secant pi over 4 is square root of 2. And how do we know? Because you can go on a side. Well, remember secant t is 1 over cosine t. So if I know cosine t, which is 1 over square root 2, then we know that the secant t will be square root of 2. Okay, minus, so tangent of 0 is 0 and secant of 0 is 1. So we end up getting 1 plus square root of 2 minus 1, or just square root 2 as our answer. Okay, looking at the next example, again notice we cannot write the, it's not easy to write the antiderivative in just this form, so we change the form of the expressions or our functions. So we can write it as x to the 1/2 and or plus x to the 3/2. And now we can apply the power rule. So according to the power rule, the antiderivative of the first term, x to the 1/2, will be x to the 3/2 divided by 3/2, which becomes 2 over 3x to the 3/2, plus in the same way x raised to the power 5/2, and on the side we are getting 2 over 5. So 1 to the 1/4. So these are the limits. Now we plug in the limits, and we have 2 over 3, 4 raised to 3/2 plus 2 over 5, 4 raised to 5/2, and I'll keep it in parentheses, minus, now I do the same thing with the other one. So 2/3 into 1 raised to 3/2 plus 2/5 into 1 raised to 5/2. So 1 raised to any power is just 1, so that one is simple. How do we tackle these ones? Well, again, go on a side. Well, 4 raised to 3/2. Remember, the exponent rules says that we can write this as 4 to the 1/2 whole raised to the power 3rd. But 4 raised to 1/2 is 2, well, because that's square root of 4. So it becomes 2 cube, which is 8. In the same way, 4 raised to the power 5/2 will be the square root of 4 raised to 5, or 2 raised to 5, which is 32. So I have 2 over 3 times 8 plus 2 over 5 times 32 minus 2 2 over 3 minus 2 over 5. So let's so I have 16 over 3 minus 2 over 3 plus 64 over 5 minus 2 over 5. So take out a calculator and do your calculations and you get your answer. So what is the answer? Let's see. So I end up getting 256 over 15. Now again, if the question doesn't say find the answer up to 2 decimal places or 3 decimal places, then you will leave your answer like this. Do not convert it into decimals. Okay, so this is how we solve the definite integrals. Next, we will look at section 5.5.